Hello, in this video we're gonna calculate the stalks of the structure sheaf of an affine scheme. So let's state it as a lemma. Let's take an affine scheme X, so X is the topological space, and OX is the scheme, so is the structure sheaf, sorry, and that's the spectrum of a ring. So that's an affine scheme. So the topological space is just a prime width. That's a risky topology, and the structure sheaf we've seen it in a previous video defined on a basis. And we've then extended it to the whole space. Okay, so that's the setting. And now we're gonna calculate the stalk at a point X. So OX and then at little x, but we're just gonna write this as OXX. And the claim is that this is the local ring, so the localization at Px, where Px is basically x, but so sometimes if we consider it as a point, we write x, and if we consider it as a prime ideal, we write Px, so that's just notation, but it's basically the same. I could also write this as OX, at a prime, at a prime P is equal to the localization of A at the prime P, and in particular it's a local ring. So that will also be important probably in the next video when we'll introduce locally ringed spaces. So let's prove the lemma. So first note that principal opens form a basis, so we can write the stalk in the following way. So that's the stalk. That's a direct limit or co-limit over the elements in A, such that X is in this principal open. So at first we would take the co-limit over all open sets in which X is, but as we have that the principal opens are a basis, we can just restrict to them. And then of course we have this OX of D of F, but we know what that is. So at first let's write this condition a little bit differently. So that's just the F and A which are not in Px, and we can write this, so we've defined it as the localization at F. Okay, so that's what we have, and now what we want to show is that this is equal to this local ring. How do we show it? Well, we use the universal property of the direct limit. So at first it gives us a map. So we have this map from the direct limit into the localization at Px. So why do we have it? Well, we have this map for all f, not in Px, we have this map into Px, and this gives us, well, actually we don't need the universal property yet, just that we get this map from the co-limit into here. But it's part of the universal property, so we don't need the whole statement, but so we get this map. And now we need to check that it's bijective. How do we do this? So let's first check search activity. Let's take an element in here. So that's of the form A over G, where A is in A and G is not in Px. And now let's see. So we have this diagram here. So we look at this localization. As I mentioned before, we have, or probably I didn't, I'm not sure have I mentioned. Well, anyways, we have this map into the co-limit, and from here we have the map to this. So also in order for this map phi to exist, so here we have phi, we would have to check compatibility of these maps, which we haven't done, but they are compatible, so that's okay. Okay, but now we see clearly, well, we just take a pre-image in here, in AG inverse, map it onto here, so map it from here to here, and as it factors, this map is surjective. So this gives us surjectivity. And for injectivity, let's take, again, basically we consider the same diagram. So we consider the pre-image of something that maps to 0 here. So the pre-image is in here. So we consider A over G to the N, which is an AG inverse, for G which is not in Px, which maps to 0. So phi of A over G to the N is 0. So we, as I said, we pick just a pre-image of something that maps to 0. Okay, and now what we have then is just by definition of the localization. So definition of the localization here, because we are now, so this is in APX. This means that there exists some, let's say, H, which is not in Px, such that H times A is 0. Okay, but H times A being 0 means we just look at this A over G to the N in a different local ring. So what do I mean? So we get a local ring in which this is 0, namely A over G to the N is 0, and sorry, it's no local ring, it's a localization. So this here is a local ring, this is not necessarily a local ring, but so we look at this in G H inverse. and this is 0. So what this tells us, let's draw it in the upper diagram again. So we have H, G, so yeah, G, H inverse, and we also have a map here, and we also have a map from, let me give it in the right direction, so it goes from here to here. So this means that the image of a over g to the n in the co-limit is 0, because it's already 0 here, and therefore this means that this map is injective. So phi is injective, which proves the lemma. Okay, so now we know that we have that the stalk of the structure sheaf is a local ring. It's the localization at this prime. And as I said before, probably in the next video we'll introduce locally ringed spaces, and hopefully we can then start to consider soon general schemes and have the definition for a scheme. Okay, thanks for watching, have a good day, bye.